Hiya, Michael here with a quick video. It's a layout exercise. So we're going to learn how to lay out stuff properly, and I'm looking specifically at substitution into formulae. So first of all, let's look at the general principle. Here we are. When you're laying out a calculation, first of all, write down the formula that you're using. That's essential. And then over on the right hand side, you write the data. That means the stuff that's going to go into the formula. You then put the data into the formula, do your calculation, and when you get your final answer, remember to underline it. So there's the general principle. Let's have a look at an example, shall we? Okay, so here's the first one we're going to look at. And it says find the volume of a cylinder of radius 6.2 centimetre and height 8.4 centimetre. Use the value of pi equals 3.14. Okay, and it actually gives me the formula here. Now I'm just going to make a quick sketch up here. So I've got a cylinder, there's the top, there it is. I know the radius and I know the height. So that's what I'm going to be looking at. Great. Now let's get it done. So the first thing I'm going to do is write the formula V equals pi r squared h. And then over here, I'm going to write the data. I've got r equals 6.2 centimetre and h equals 8.4 centimetre. Okay, so I've got the formula, data. Now I need to put it in. So that's equal to pi, that's 3.14, that's what it tells me, r 6.2, but remember it's r squared, so it's 6.2 squared times h, which is 8.4. Do you notice I put the units in the data, but I don't put the units in the calculation? Right, now let's put that on the calculator and get the answer down. Okay, so here's what I've put on my calculator. 3.14 times 6.2 squared times 8.4. Let's press equals and see what we get. And we get an answer of 1013. Now then, I've only got two significant figures in. I've got three significant figures here, two here, two here. So I'm going to give my answer to two significant figures. So I'm just going to call that 1000. So here we are. I'm going to call that 1000. And I need to remember the units. Now it's volume, so it's centimetre cubed, and I underline the answer. And then I've done the job perfectly. Formula, data, calculation, answer underlined. And that's what your work should look like. Right, let's have a look at another example now. Okay, so here we've got number 2. So we've got a truck travels the 200 kilometres from Birmingham to London in 2 hours and 25 minutes. That's what that means. It's not 2.25 hours, 2 hours, 25 minutes. And we want to know what is the average speed. And we've got the formula speed equals distance over time. I don't think we need to draw a diagram for this now, do we? So we've got a distance of 200 kilometres in 2.25 hours. Well, I want to convert that to a decimal, and actually I've cheated and already done that. It works out at about 2.4 hours as a decimal. You can easily confirm that. The 2, of course, doesn't change. 25 divided by 60 to give you a decimal, and it gives you about 0.4. I'm just working for two significant figures here. Okay, let's write down the formula. We've got S for speed equals distance divided by time. And my distance is 200 kilometres. My time is 2.4 hours. So now all I need to do is put those numbers into here. Notice I keep the equal signs lined up. So that's 200 divided by 2.4. Again, notice I have the units in the data, but I don't put the units in the calculation. Okay, let's put that on the calculator then. Okay, here we are. 200 divided by 2.4. Press equals. And there we go. What do we get? It's about 83.3. Well, I'm only working to two significant figures, so I'm going to call that 83. So here we are back again. It's 83 kilometres, hours, so it's kilometres per hour. Some people might write that as kph. Either is okay, it doesn't matter. And of course I underline the answer. So we've got formula, data, calculation and answer. Absolutely perfect. And like I said, that's how you should lay out your calculations. Right, let's just have a look at one more. Okay, last one here. So a 380ml glass of Coca-Cola has a mass of 370 grams. Okay, 380ml glass of Coca-Cola has a mass of 370 grams, and it says calculate the density of Coca-Cola. Give your answer, in kilograms per metre cubed. Now it gives me the formula here. Density equals mass divided by volume. And it also tells me that 1 mil is 10 to the minus 6 cubic metres. So I'm going to need that information. I don't think I need to draw a diagram for this. Okay, so my formula, density, I'll call that D, equals mass divided by volume, M for mass, V for volume. Okay, let's get the data down. Now, it asks me for an answer in kilograms per cubic metre. So I'm going to put the mass in kilograms. 370 grams, I can do that in my head. 0.37 kilograms. Now for the volume, that's 380 mil, and I've got to divide that by 1,000,000. So it's 380 divided by 1,000,000. I'm actually going to put 10 to the 6 when I do the calculation. Right, so I've got everything I need there, haven't I? I've got the formula and the data. All I need to do now is do the calculation. So it's 0.37 divided by 380, and that is divided by 1,000,000. Like I said, I'm going to put 10 to the power of 6 in there. Okay, let's do the calculation now. Have a look at the calculator. Okay, so this is what I've got on my calculator. I've got 0.37 divided by, and I've put this in brackets to make sure that these stick together, the 380 and the 10 to the power of 6. Okay, let's press equals, and okay, press SD. 973. Okay, I'm going to call that 970 because I'm only working to two significant figures. So here we are. We've done the calculation and it's about 970. Remember the units, kilograms per metre cubed. Oh, I wonder if you noticed here that I forgot to put the units. I put the units for mass, but I forgot to put them for volume. So that's metres cubed. Right, and remember to underline the answer. So again, I've got formula, data, calculation and an underlined answer. And I'm sorry to get boring, but I'm going to say it again, and that is what your work should look like. Okay, let's go right back to the beginning and check what we've done. Okay, so it was a layout exercise, substitution into formulae. And how did we lay out all the calculations? Well, we laid them out like this. We wrote the formula, put the data at the side, then did the calculation and remembered to underline the answer. And each and every time we came up with an absolutely perfect piece of work. It looks good, it's easy to follow, and of course you get the right answer at the end. And that's what we're looking for. First class work, first class answers. Okay, Michael signing off now. I hope that was a useful use of about 14 minutes of your time. Bye now.